Hello and welcome to our Hitchhiker's Guide for Upgrading to Oracle Database 23 AI workshop. This workshop is much more than just upgrading from Oracle Database 19c to 23 AI. Oracle Database 23 AI is the next long-term support release, and in order to show you all the different ways moving there, you will not only do a simple upgrade, you will upgrade and plug in with AutoUpgrade from 19c to 23 AI into a container database environment. But in this workshop, you will also get to know other techniques to move to 23 AI, such as using a refreshable clone, or an unplug plug upgrade, or a migration with data pump, a migration with full transportable export import, and you will do a similar exercise also with an encrypted database. In order to get you more real-world texture in that lab, we also run an application before the upgrade. We collect statements, then we upgrade the database, and afterwards we check and verify whether the application is still running fine. We use our toolset from the SQL Performance Analyzer to verify statements behave, or those statements which misbehave, we will treat them with either SQL Plan Management or the SQL Tuning Advisor. This lab gives you all the freedom, so you are allowed to step right or left. You don't have to follow the entire track, but in this recording, of course, I will show you how we can move forward step by step and go through the labs, 1 to the last lab 15. But you are free to also use different tracks or do only parts of the lab. What you see here is the instruction set. You have this open on your page. So I started with getting started, the introduction. And in all the labs, you can expand the tasks. So I click here. And what you see in the lab here is first the overview of what you get inside. So you find 19C databases, UPGR, FTX, 2 non-CDBs, and already a CDB19, which is a container database, with 1 PDB, the orange PDB. In the 23 AI environment, you find 2 CDBs pre-created, CDB23 and CDB23.com, and both have a different set of PDBs. Now the important part is marked in blue here. This is how you switch between the environments. It's always a dot, then a space or blank, and then UPGR, for instance, to change the environment to the UPGR database with all the homes and all environment parameters you need to have, or dot blank FTX or dot blank CDB19, and for 23 it's dot blank CDB23 or dot blank CDB23com. Now when you approach the lab, you can do different tracks. So in any case, you need to start with 1 and 2, and we will do this together, but then you can do things at the same time in parallel. So whenever there's a waiting period coming in, let's say you wait for the upgrade to complete or the plugin to multitenant, you can take then a side route. And in order to do these routes, you may use down here in the lower right corner, you see the 1/2. You have multiple workspaces. And as soon as you open a second workspace, there will be a third workspace opened automatically. So you don't have to overlay windows over windows. You can also use the different workspaces for the different tracks of the lab. So we will do AutoUpgrade. We will do migration data with data pump. And let me just start here with initializing the environment. So first lab we really need to take care on is to initialize the environment. Let me start here, and what we do at first is, so this is our desktop, and before copying paste whatever, take notice of the commands you execute. I will show you how that looks like. And in order to execute the commands, we need a terminal. So you see this marked here and it's on my desktop over here. So I double click and I open a terminal, and I will move this over here a little bit and also enlarge it. This should be enough. In the terminal window, when we scroll down here a bit further, in the terminal window, you can also zoom in and zoom out. So depending on the size of your screen, it may be needed for better readability to zoom in, or if you have eagle eyes, to zoom out. And the same applies to the browser. So for the environments, we use Firefox, and you will see later on that some of the reports open with a pretty small font size. So it's good to either use the zoom option here in Firefox, or to use the Control++, Control-, commands on your keyboard to zoom in or zoom out. Then what is important here, let's go forward with task number 2. You see the gray boxes. So in our environment, there's already a listener set up, and there are several database instances already up and running, but let us double check that. And whenever you see such a gray box, you have the option to not type, but use the copy command. This is exactly what I'm going to do here. And then the right mouse button and paste. So now if you're uncertain whether this output here is correct or not, let me go back to the instructions. You see this red marked click to see the output. So if I click here, then we show you what the output is supposed to be. And ideally, this matches. Then let us check which databases are up and running. And here we have the UPGR database, the FTX, and the CDB23 database. And let me double check again. This is what to expect here. So we are already done with the lab number 1. Let's go on from here to lab number 2. In lab number 2, we would like to explore now the multitenant architecture. As you know, the multitenant architecture is mandatory since Oracle Database 21c already, but most of you will experience that first time when you move to 23 AI. So we thought it's a good idea to start the entire lab not with upgrading, but first getting familiar with multitenant by itself. If you are a multitenant expert already, you're free to skip that lab. Nothing in the lab is mandatory for the later progress of this Hitchhiker's Guide to upgrade to Oracle Database 23 AI. But if you're not worked with multitenant before, or if you are uncertain, if you know some of the tricks we would like to show you, then you please march through. Estimated time is about 10 minutes. Let me expand here the tasks. And the first task is we simply want to connect to our CDB23. So what we'll do here is we will switch to the CDB23 environment, and then we open SQL+/sysdba. Now, one thing you need to take into account, there's a reason why we say be sure to hit return here. Because as soon as the environment has more than one line in a gray box, you need to hit return. The first return is automatically happening, setting the environment, but otherwise the X term will remain in that state and wait for the return, so you may get in trouble. Let me copy paste that to my X term and then hit return. And you see I'm connected now. And my next task is to show the PDBs, and this is a quick command. So let me type this briefly. And we see that we have 3 PDBs in our environment and the default created PDB $seed. Just remember, since Oracle Database 19c, you can have 3 user-created PDBs without an extra license set required. Even in Standard Edition 2, this is included, and a PDB $seed does not count here. So this is the maximum you can have without the multi-tenant license. Let me scroll down a bit. And next task would be to start the PDB called blue. Let me do that, because you see PDB blue is only in mounted state. Let me start it. And we have alternatives. So let us look at the PDBs in a different way. And again, since this is a multi-command box, we need to type return. Now, in this case, we went on $PDBs instead of just using this SQL Plus shortcut saying show PDBs. And you see the blue PDB is now also open, read, write, and unrestricted. Let's move forward. And we have a different way of looking at things. Just let us get a list of containers. And therefore, we have the view $containers. And now you see one difference to the previous output. While we checked $PDBs before, when we check $containers, we see also the CDB $root with the container ID 1. Next thing is, by default, it would be always good if our PDBs start by itself. So whenever we have to take down the CDB $root and start it up again, it would be great if the PDBs would go back into the previous state. The PDB $C does that, but all the other PDBs don't do that. So what I'm going to do is here, I select the open mode for blue. So open mode is read-write. Then I say save state. Save state means, please, whenever it gets restarted, you go back in this state I saved, which is open, read, write. And then I double check, and that state is open. Let me repeat that also with, we check this here, so you see the output here. But let me repeat that exercise also with the green PDB. The green PDB is not open yet. Let us open it as well, and then save the state. And this is also done. And from here we can exit now from SQL Plus. Because I would like to go on the command line and do an lsnr.ctl status and see if all my databases are registered nicely with the listener. And it looks pretty good, so nothing I should be worried here about. But now, since we know that the PDBs have services, there's a different way of connecting to the PDB directly. So you saw when I connected before, I connected into the CDB $root automatically as soon as I do /sysdba. Now let us connect here with add localhost /red. And again, there are different ways to check whether I'm really connected to the red PDB, because as you see, the SQL Plus line doesn't tell you. So do a quick check. Select userinf, conname. And you may realize one cool thing in 23AI, there's no select from dual needed anymore. So you can directly select what you would like to select here. And it says, yes, it's the red PDB, all good here. Let us now switch to the green one. And since we are connected already, we can do this quickly with an alter session set container green. And whether I would like to know if I'm really in the green PDB, I can just say show con_name, which I do here. And it tells me the container name green. Wonderful. Now let's move a step forward and see how we can check certain parameters. For this purpose, we move back into the CDB $root because most parameters are set on the CDB $root, even though there are a few parameters you can change and adjust individually on a PDB level. And therefore, we check $system parameter here. And we check for the default values for, in this case, SGA target and undo table spaces. A few parameters are set in the PDBs, so notice that, only a few of them. And all other parameters, except for those, rely on the CDB $root. So let us do the following. Let us connect to the red and raise SGA target to 500 meg. This will set now a minimum allocation for the red PDB. So we do this here, and let's check whether we did the right thing. I'm in the right PDB, and see here, I changed my SGA target for container ID 3. I scroll up quickly here. So you see here, it was set to 0, so unspecified, which means it adopts the value setting of the CDB $root, and then can basically, the database decides how to size it correctly. Now I want at least 500 meg being allocated, which I set in this case. Let's check also a few of the views, because one of the benefits of the multi-tenant architecture is having this super dictionary in the CDB $root, where I can basically query a lot of things from my PDBs. So when I check here just DBA table spaces, this is supposedly only the table spaces of my CDB $root. So you have system, sysargs, undo, temp, and users. If I want to see now all table spaces of all my containers, oops, let me query this as well. So in this case here, we join CDB table spaces with $$ containers. Let's do that. Now you see the con ID, CDB $root, with the table spaces red, blue, and green PDBs with their table spaces. What you may have recognized is that we missed the table spaces of PDB $seed. Con ID 2 is missing by default. Now you may say, why should I care about the PDB $seed? I only need the PDB $seed when I create a new PDB, because then it clones the seed and adds some stuff to it. But our experience has shown us that it's always good to see also the objects of PDB $seed, especially when you patch, just to avoid that you have any invalids, or when you do time zone changes. It's always good to see what's going on in the PDB $seed. So let us set an underscore parameter, and the underscore parameter is exclude seed CDB view, and we set it to false. By default, this value is true, and it means we hide everything belonging to PDB $seed. Now I don't want to anybody or anything being hidden here. I would like to see everything. And when I repeat that query, now we see also the objects belonging to container ID 2. And this is the PDB $seed. So also it has a system, a sysargs, temp, and an undo table space. Then one of the most powerful ways to query stuff in a multi-tenant environment is the containers clause. So you see this here in the instructions marked in red. And this is incredibly powerful, especially when you write scripts. Instead of doing this long thing above, I can quickly use the containers clause and query the table space names from all my containers. So I see them here, and of course I could order the same thing as well if I need to by con ID. This is just not in that query here. Then the multi-tenant architecture isolates things from each other. Let us do another thing. Let's go to the green PDB and repeat the same query from before. Even though I query CDB table spaces and $$ containers, since I'm in my PDB green, even though I'm connected as /sysdba, I only see now the table spaces belonging to container ID 5. I don't see all the others because I'm inside the PDB. Therefore, this is one of the strengths of the multi-tenant concept. In addition, it's the isolation. So let us now exit SQL+ here and go to the next exercise. We want to run a script. And what we are going to do here is we use a very powerful vehicle to execute scripts. And this powerful vehicle is called cut-con-pl. So cut-con-pl is also something we use. So when you do upgrades or when you patch or whatever, underneath the covers, we use cut-con-pl and cut-con-pm, the library attached to it. And the idea is now, when we do a help here, you see it has a lot of options. It will quickly scroll through the screen. So I briefly scroll up here to show you all the options it has. So it's a lot actually. Feel free to study that by yourself. But let us do a simple recompilation. And what we are going to do here is we use cut.conpl as a vehicle, and we execute util rp.sql with 2 minus n2 with 2 workers in my environment. So let us do this here. And you see it opens now 2 worker processes. And these worker processes will now start recompiling everything in my container database, including all the PDBs. And this is the power of cut.conpl, that you can execute easily things in various PDBs. Let us have a quick look at the results. Here's the result logs, and do a quick check. And we see that it runs successfully, session altered, that all looks good. And this is what we would like to show you here for a start. This is the output you're supposed to see. Now, this is what we wanted to start with, exploring the multi-tenant architecture. And from this here, we can go forward to lab number 3. And our lab number 3 is now to start with the upgrade exercise. As we told you before, it's not just upgrading a database. Upgrading is no rocket science. AutoUpgrade automates this end-to-end for you. Makes your life way more easier. You can repeat it anytime, as often as you want. It has a guaranteed restore point out of the box and many other features. But in reality, we have also an application running. And in order to make sure that the application behaves correctly, we ideally in our testing runs should go in and check beforehand. So let us start here with lab number 3. And before we exercised multi-tenant in CDB23, now we go back to 19C, we connect to the UPGR database. And the UPGR database is a non-CDB 1921. And we prepared a script which allows you to generate an AWR snapshot. So AWR snapshot, snap ID 3 got created. Take note of that snap ID. We will need it later on. Now follow our instructions. We said, hey, don't exit the terminal. Keep it open. But now we're going to start a tool. This tool is called HammerDB. So we will double click on the HammerDB icon on the side here, over here. And what we do with the tool, I show you briefly up front. So this tool is a benchmarking tool, and it will run a TPCC load on the UPGR database. So we prepared already some warehousing schemas in that database, and there's data in a specific table space called TPCC. Then we will load a driver script. So you need to double click here on the driver script icon, or click once, but you need to double click then on the load button. And once you loaded the driver script, it will appear on the screen. So in the script editor here, you will then find a complete script. There's nothing you need to modify. Next step is then we expand the virtual users and double click on create. So then we will have 3 virtual users and 1 control user. And then we are supposed to start a workload. But before we start a workload now, we need to run another script. So let me do this briefly. So I will start HammerDB. So I will click down here and go to driver script. And double click on load. Now the script is loaded. I will go to the virtual users and double click on create. And we prepared a tool to create 3 virtual users, but don't click on run yet. We go back to the instructions, because what we're going to do is in the background, we would like to capture now directly from cursor cache. The capture from cursor cache basically puts like a microphone into the cursor cache, and then we record all the statements. Why are we doing this? Because this is an OLTP application, and in an AWR snapshot, there's a limitation of how many statements we can collect. Now in our environment, there will not be a huge divergence between capturing from cursor cache and AWR, even though there will a little bit visible divergence. You'll see that. But in reality, the idea is really if you have OLTP load, you should capture from cursor cache, maybe poll the cursor cache every 5 minutes and capture the statements. Because in AWR snapshots only, you would miss a lot of your short running statements. But some of the statements may be executed like millions of times and you still want to catch them. So let me start the script here. So this is now going in the background and waiting. And while I'm doing this, I can now click on run, and then I go up here to the staircase sign. And then we will see the transaction load pushed on the system at this point. So quickly it will start syncing. And now you see we run currently about 70,000 transactions per minute on this little tiny innocent UPGR database. So I hear it already aching here a little bit. And while it does that, the load will approximately run for 3 minutes or a little bit less than 3 minutes. We scroll down and see what the next steps will be. So this is what we see right now here on the Xterm. The script is in the background. It polls now the cursor cache every 10 seconds. Don't do it every 10 seconds in real life. Start with a relatively mild interval of maybe 5 or 10 minutes. And if you are fine, you can increase the frequency and poll it all more often. But be aware that this really generates load on your environment. So be a bit careful when you start that. If you need the scripts, you'll find them on the upgrade blog on mikedietrichday.com/scripts. There you can download them. And of course, feel free to change and adjust them for your own needs. There's no copyright on these scripts. So we have the tool running and we wait until it's complete. Our next step would be then, once the tool is finished, we exit HammerDB and then we will generate another AWR snapshot. So I put this already in a clipboard and go to the background. So you see now the workload has finished. We have collected 43 statements from cursor cache. And let me do another AWR snapshot now. And this is the snap ID 6. So I take note of the snap ID 6 as well. We will need this later on. And let's go on with the instructions. We exit from SQL Plus. And let me connect another time. This is an optional exercise. We would like to show you quickly how to export the AWR. Purpose of that exercise is if you have a project and you want Oracle support drilling into certain details, you can always share the AWR extract with Oracle support, and the support engineer could import it into a test database and see your performance markers. So in order to do that, let us connect here quickly to the UPGR database, to SQL Plus, and then I execute a script called AWR extr for extract in rdb-admin. Now here my DB ID is the standard. It presents me the DB ID. I can go with that. Just return. I'm going for 1 day. This is the current day. And now you see the existing snapshots in the environment. So it's snapshot 1 until 6. And I would like to export my AWR from 3 to 6. This is the period I run my application. And I export this here to my data pump dir directory. And I take the standard name the tool presents to me. and it uses AWR dot underscore 3 underscore 6. And now in the background, it triggers a data pump export of the AWR, and a support engineer would be able now to import that into a database and do some analysis. So extract it, put the data in, and we can have a brief look once this is completed. Now, since it is completed, we exit from SQL Plus. We check quickly the file. It is a dump file and a log file, and let's have a brief look at the log file. What it exported. So you see basically all the AWR tables it exports, and all is good. From this here, we can go to the next lab number 4. And lab number 4 is now meant to capture and preserve the SQL. Because there's a reason why we did this exercise. We collected statements from capture cursor cache, but we have also AWR. So let's go in and connect again to our UPGR database. So we are in UPGR, and now in addition to capturing from cursor cache, you remember we collected 43 statements. Let's capture also from AWR. So this is now capturing for the same period, and you see it takes the entire snapshot range here from 1 to 7. There are 35 SQL statements. Why are there less? AWR doesn't collect all the statements. It's the ASH, the active session history, which is a circular buffer, and only a part of the ASH will be collected into AWR. This is why we emphasize that for OLTP environments, you better capture from cursor cache as well. Now let's compare the two ones just to double check. And you see we have two SQL tuning sets. STS stands for SQL tuning set, capture AWR and capture cursor cache, 35 and 43 statements. Now let's exit from SQL Plus. And that was basically the entire lab number 4. Let's go to lab number 5. And in lab number 5 now, you see the estimated time is a bit longer. We would like to upgrade now the database. And in order to upgrade databases, there's only one supported way in Oracle 23 AI, and this is AutoUpgrade. So the old DBA has finally retired. It is not supported anymore. Neither is it supported to do command line upgrades. Please use AutoUpgrade. So let us start here with that simple exercise. Switch to the UPGR environment and go to Home. And in Home, we stored the newest AutoUpgrade tool. So what does the tool tell you? It tells you it's the version 24.4 from April 26 in the year 2024. It's the production version. And in case you're going to check for a new AutoUpgrade tool, we also give you the Moz node here, and we give you the link to the Moz node to download a newer version. Every 8 weeks in average, we refresh the version, and in the Moz node you find also, when you scroll down to the bottom of it, all the release changes we did with each incarnation of AutoUpgrade. So be always prepared that they are not just fixes, we roll out constantly new features. Then AutoUpgrade could create a sample config file, and we will do a quick check here. The sample config file, let me go down here. It shows you a lot of comments with the hash sign. So basically only these few here are not or real parameters. It shows you different ways of upgrading. We may come around with a better option of doing this pretty soon. And since we don't want you to waste any time with editing such a sample config file, we prepared a config file for you. So let me briefly explain what that config file here, upgrcfg, contains. First of all, the most important thing as a start, you see here global and you see upg1. Global means that applies to all databases you cover in this config file. A config file can cover up to hundreds of thousands of databases. There's no physical limit. And it could upgrade all your databases at the same time, just if your server is able to hold such a load. We have customers who upgraded 40 databases in parallel on a bigger machine, an ODA for instance. And then you see upg1. So upg1 is now for an individual database. It's a prefix you can define by yourself. We name it upg1, upg2, but you can also name it Mike, Daniel, Klaus, Rodrigo, Alex, whatever. You're absolutely free to set the prefix to the database name or description you'd like to have. Then we tell it the source home. So the source home is our 19C home. We tell it the target home, it's a 23 home. And the database SID we're going to upgrade is the UPGR database. Now the UPGR database is a non-CDB. We can't just upgrade it because there's no non-CDBs anymore in 23AI. We need to plug it in as well. And this is why we specify target underscore CDB 23. So it will be plugged in first, and then it will be upgraded, and then it will be converted into a PDB. Now by default, AutoUpgrade writes a guaranteed restore point. In order to save time and not spill around with logs and whatever, we have no archive log turned on here. So we intentionally skip restoration equals no. We skip for this environment the guaranteed restore point. By default, it would create one. And we also want to add a parameter. So add after upgrade p file. This points to a text file where we set additional parameters after the upgrade in our database. And since we may want to downgrade later on, potentially, we want to also skip the time zone upgrade. So time zone, UPG, no. Reason for that is you can't downgrade time zone. When you use AutoUpgrade, you could start right away, but we recommend that you run an analyze first. So -mode analyze. Let me do this here. So you see java -char, AutoUpgrade char, then our config file, and -mode analyze. This analyze runs pretty fast. So I can quickly try an LSJ. So we see the job number 100 is pre-checking, and while I talk, the tool already finished and has completed the analyze. It's important to understand that the analyze is non-intrusive. You can run it as often as you want. It doesn't write or change anything in your source database. It just reads information. So nothing is changed, nothing is done. You can even run the analyze on a standby if you would like to. Let us now examine the log file. So we have this status log. And what I would like to see in the status log, so it's my UPGR database and the status is successful, that's good. It will be 23.5 after upgrade and is 1921 right now. And the important line I'm looking for is check passed and no manual intervention needed. That means for me, I easily could move forward. But you saw there was also a second log here. So there's the status log. And there's also the HTML log. So if you want a bit more information than just, hey, all is good, trust us, then you can open also the status log. And you see here, it's one job. It's the UPGR database. So name of the database UPGR. And let us check the report. So the database here is the UPGR database. We would like to check the report, and we see now findings. So what do we have here? We have unified auditing on as a check. There's no fix-up available. So we would like to remind you that traditional auditing is currently found in the database. It will still work onwards, but you should change to unified auditing because your traditional auditing is not supported in 23i, even though it works for backwards compatibility. Then we have some target CDB compatibility warnings. Nothing serious about that here as far as I see. And here, for instance, we have a check where you say, hey, dictionary statistics, but there's a fix-up available. So it checked and found out, hey, Mike, your dictionary statistics are a little bit old, so I may refresh them, but I will do it for you. So this is where you can scroll down and we come to also things important after the upgrade. So there are certain things to mention here. All good. I think we can close Firefox and just go forward with our upgrade. So here we explain the different ones, size settings in Firefox report, what you see here. And now let me kick off the upgrade. So let's do a fresh screen. What I do now is AutoUpgrade with the same config file, but now I do mode deploy. And when I do mode deploy, it will kick off the database upgrade. And what we do here is, because at the beginning you see nothing, so we type in the most simple command, it's called lsj. List job, lsj. You see, list the job, it's the job 101. And now we can do some checks on the environment to see what we can see. If you are tired of typing, same as in SQL+, you can use a slash and just repeat the last command. Or if you want the lsj repeated like every 30 seconds, you say -a 30, and then it will auto-repeat every 30 seconds, the command. So then you don't have to sit there. There's also on disk a status HTML file, or state HTML it's called, and if you pass this on the browser, then the browser does this auto-repeat and auto-refresh, and you can follow the upgrade and the plugin also in the browser. But there are more commands. Let's do a status -job101, for instance. Now you see it does an auto-refresh every 30 seconds, but I can press simply enter to break this. And let us do a status -job101 and get some more information. Scroll up a little bit. So here's the command. I executed status job101. This is telling you where all the logs are. And AutoUpgrade writes for each of its phases a separate subdirectory. This makes it really easy to diagnose anything not working as intended in case something is coming up. And you see the different phases we are approaching here. So setup has been done, pre-upgrade is done, pre-checks have been done. Now at the moment while I execute that, we are under pre-fix-ups. For instance, it will refresh now dictionary statistics, then it will drain the connection, it will start the upgrade, this is the longest phase typically, then it will non-CDB to PDB conversion, it will do post checks, post fix-ups, post upgrade steps and sys updates, whatever is needed. And you see also the progress. So for the pre-fix-ups where I was running, it had completed 40%. Let us repeat the command and see where we are right now. So now we have completed the pre-fix-ups. We are in the drain phase and there's nothing to report in the drain phase. So let me repeat this again. Still in the drain phase while it is draining. We check going forward. We could also go into a second environment here if we want to. Let me do this and just go to the other window and just climb down and do an... Here you see the directory structure. So you see 100. This was my analyze run. Now I'm in job 101. So if I go in 101, then you see we have the directories, pre-upgrade, pre-checks, pre-fix-ups, drain, and DB upgrade. Now DB upgrade has been created, so it's likely that the upgrade runs already. Let me go back here and check the status again. And you see, true thing, it has started the upgrade, it is running already, and 0% have been upgraded. If I want to auto-repeat that, let me put this in every 30 seconds. Then I don't have to do this by myself. But I would like to also show something in addition, which is not in instructions. If you want to monitor now your upgrade, you go to DB upgrade. Because every upgrade has multiple workers, and here we have 2 workers running. So if you really want to see now what's happening, what's going on, we could do a tail minus F. On the 0 worker, the 0 is always the main worker, and then it will branch out. And then we see the upgrade basically running in the background. You can monitor everything. So the tool is not a black box. The tool is really meant to show you everything, to completely tell you all the bits and pieces. And I will let the upgrade now progress. So the upgrade has been completed now. It's time to go on to the next lab. We want to compare now AWR periods from before and after. The database has been upgraded. We clear the screen here and now switch to the 23 environment and connect into my UPGR PDB. Let's do a quick show con name. So I'm in the UPGR now PDB, and there we would like to get a new AWR snapshot. I take also note of the snapshot ID. This is snapshot ID 12 in this case. You remember before it was 3 and 6. I leave the terminal open. That is important. And the idea is now that we run the application again. So I start HammerDB a second time and do exactly the same steps as I've done before. Run it again and take an AWR snapshot afterwards. So let's do that. I load a driver script. I create the virtual users, and now I can kick it off directly and let it run now against the PDB. The load has been completed. We take another AWR snapshot after the load has been run. Snapshot ID is 15. And now the idea is that we can compare, because we had the same load before and we have the same load after upgrade. And let's compare now the 2 snapshot intervals to each other. And the script we are using is awrdd rpt. So let's execute that. And I want an HTML report, which is the default. And in this case, I would like to have a report for the AWR PDB, not for the root. Number of days, we can easily go with 1. And the snapshot ID I would like to compare at first is 3 to 6. So the begin snap here is 3. And the end snap for the first period is 6. And again, for the second period, 1 day. And here in this case, the begin snap was 12. And the end snap When the application was completed, it was 15. I go again with the default report name. And then we will see quickly a lot of output on the screen, writing HTML code into the file. This makes only sense if we have comparable loads. So let me exit here from SQL Plus and then call Firefox to check the file. Let me also increase the fonts, the zoom size here. Zoom to something better readable. This is okay. So we have the first run. The database was UPGR. Now the second run, the database name is CDB23, but we ran it for the PDB UPGR. And we can compare now the periods to each other. So you see always the first and the second. So the markers here for the host configuration should be more or less identical. But the interesting part and where we start to look at first is the events. So the wait events. And when we look here at the top time, the wait events, we see log file sync and log file sync. This is expected. Also the waits are almost exactly identical. So that's a good sign actually. And then we have CPU time. The interesting part is in 23AI in the second run, I have here a transaction row log contention, which may be caused by some change in the code. I don't know. When we compare on this side, this was still same number, almost same number, so it's not that significantly different. The times here are shorter. But I will drill now a little bit further. So the idea is really to look for some sort of indication if something is jumping into your eye, if you want to investigate further. Here again, the wait events, the comparison before, after on DB time and so on. So this is quite interesting. It is a first checkpoint. And it makes only sense, again, let me repeat that, if you have comparable load. If you don't have comparable load before, after, it makes absolutely no sense to run AWR diff report. So we explain this here, and then we are already done with lab number 6. Let me continue now with lab number 7. Lab number 7 will take us about 10 minutes here, and it's now the SQL Performance Analyzer. What is our focus? We would like to find the misbehaving statements before, after. Let me expand the tasks. So again, we connect to our UPGR PDB now. Quick check, show con name. Yes, I'm in the UPGR. And let me check again quickly the SQL tuning sets. They both should be still there. So the STS capture AWR and the STS capture cursor cache, both are there with the 35 and 43 statements. And this will be now our basis for a performance comparison. We would like to simulate these statements in 23AI and see whether we have any sort of divergence or problematic statements. Our problem we have here, you saw that the transaction rates are a little bit higher than they were in 19C. The 23 AI code seems to be really, really good. Our workload runs faster out of the box. This lab would be over at this point because we can't find any sort of broken statements. What we do now is, and I show you that here, we have a parameter called optimizer index cost adjust, and it's set on the default 100. So what we are going to do now is we artificially will make the simulation run bad. This is simulating the case that you go to the new release and some things are misbehaving. In our case here, nothing is misbehaving, and trust us, we tried really hard to make it misbehave. It's not so easy. So 23 AI seems to be really, really good in that regard, at least with our TPCC workload. So what you are doing here is we make index scans really expensive. So we raise this parameter now to 10,000. So we forced the database to prefer full table scans over index scans. So parameter has been set. And what we do now is we use a prepared script. We use a simulation script, and you can grab them again from the upgrade blog from mikedietrich.com/scripts. You find us there. Spar CPU, the script will convert now the SQL tuning set into the right format, then simulate the execution of all statements in it. And we could do the same thing with the capture cursor cache. We just do it here with one of them, but in reality you would now take both of the SQL tuning sets and run the task. And then we compare before after. So let me do that. And this is a quick task because it's only a few statements in there. So you see, I didn't speed up anything. It is really quickly done. But let me create now a report on it. Because what we are interested on is we want to see the statements. So the SPAR report now reports on the simulation results. And since I do this here for CPU, I would like to do the same thing for elapsed time. And in many cases, I would also go for the buffer and see how we are there buffer cache-wise, if there are some sort of significant changes. This is the typical matrix. There are 6 different comparison matrix. But I generate these two here for CPU and elapsed time. And then I exit SQL Plus and call Firefox again, because I want to see the statements now in the simulation. So let me do that here and open Firefox. So we have 2 reports here. Let me again increase the zoom factor to 140. That should be convenient, or 150. And I think I have to do the same thing for the second one here. So here we go. So first report is on CPU time. Let me scroll down a little bit. So here we see the comparison matrix, CPU time, and we have a threshold. So everything below 2% impact or 2% workload threshold is not displayed, because we want to embed a sort of an entry level. We have now some statements really misbehaving and having a significant impact. So 4 statements are terribly misbehaving. And let me show you these 4 statements. It's the ones marked here in orange. Interesting or expected, all 4 of them have a plan change. And what we would look for now is, let me take one of them. I take the second one here. When I click on the statement, I get the statement now in clear text. First of all in clear text here. I get also the binds. I get now the execution statistics. Oops, a little bit too far, sorry for that. Impact on workload. So this statement is really having a big impact negatively. I see also the costs compared to before. So value before, value after. Costs are dramatically increased. Not good. And very important, even though it ran so quickly, that statement got executed the first time to warm up the buffer cache, and then 9 additional times. So this is not a one-time shot where you say, oh, let's give it a try and see what happens, and then, hey, here, customer, this is the result. This is really an estimation over 10 runs, where only 9 runs, only the run 2 to 10 counts. The first run is only to warm up the buffer cache. And then we have the findings. So the statement has regressed. Yes, we saw that. The structure has a plan change. Yes. It returned in this case 0 rows. Okay, I can deal with that. And it's different between the two tasks. Now we have the plan before change. And we have the plan after change. And this is a quite complex plan, but even if I'm not a tuning expert, I immediately spot something. You see here, table access full. And over there, there's no table access full. Let me repeat that quickly with this other statement to see what result we see here. And I quickly go to the plan. And here it's even more obvious because it's a much shorter plan. This is the plan before with an index range scan on the customer table. And here we have a full access now. It's expected because you remember I set this parameter here in my SQL Plus in my database before in my PDB. So it's expected that it forces now full table scans. Let us do a quick check on the second report. So the second report is on elapsed time. So we look at the overall elapsed time for the statement. And again, similar candidates showing up here. Let's take the second one again. So we see here plan has been regressed. It's that plan here before, after. Of course, same statement, same plan, makes sense. I see the impact on the workload. I see the value before, the value after. So elapsed time before was really like, it was a super fast statement, and now it's significantly slower. We also have statistics on how often this statement got executed originally. So this is also important to know because this is how we can derive then the impact on the entire workload. So this is really, really important to see, and this is extremely helpful to identify these statements. So we've done the comparison. We've compared the statements. We checked the plans. What we are going to do now is, let me connect to the database again into the UPGR container. And now let's reset that parameter to the default. So now it's back on 100. And the super, super cool thing with the SQL Performance Analyzer is we just run the tuning task again. And in this case, I only run the elapsed task a second time. And I will report on it. I could do the same thing on CPU if needed. Output is there. Then we exit SQL Plus and we call Firefox again. Oops. Let me increase the zoom factor quickly. So again, we did a comparison on elapsed time, but now we had changed the parameters. And guess what? Now we have no broken statements anymore. Instead, we have improved statements, 3 of them. And we see exactly the one candidate from before. For instance, this was the first one here. This is now faster. Also, like when we look at the elapsed time, there's a significant difference here. And again, we had done, even though it was so fast, we have 10 executions. The plan is the same. There's no plan change. This is what we expect. And this is an excellent result. This is what I wanted to see. Now we had to make it really artificially run bad to show you some results. In lab number 8, we will use now SQL Plan Management to cure potentially misbehaving plans. Let us connect here to the environment, CDB23 again. And what we want to do here is to make sure that this plan is in the cursor cache. It's this plan here marked with 4WG. And in order to make sure it's in the cursor cache, we artificially enforce a load of it. This is something we do because it's essential for the progress of the lab, and in some cases, depending on how long you took, it could be that this plan has been gone out of the cursor cache by this time. I connect to my UPGR PDB again, and I would like to get now the list of available plans for this SQL hash ID. So let's do that. And you see we have basically two plans available. The one with the plan hash value PHV stands for plan hash value 612, and the other one with 4040. Now, which one is the good one? Which one is the bad one? The plan with 4040 is the bad one. The 612 is the good plan. So I have two plans available at this point, and what I want to do is I want to nail down the plan. I want to nail down the 612 plan and ensure that my database uses that. In this case, we borrow scripts written by our colleague Carlos Sierra. So Carlos shares these scripts in his Git, and let us execute that. So we need plan value. So this is what we are going to look for. Let me copy the plan hash value over there, or the SQL ID. So SQL ID is mentioned, has two plans as we saw before. So the first one, this is the good one. This is the one I want to pass in, and I don't want an alternative. So all the others, second plan, I will just skip. It's optional, fixed, optional, return. And what happened now is that we nailed down this plan in the SQL plan baseline. So the script asked for the SQL ID. This was the 4WG one. And then it displays the available plans for that SQL ID. These were the two plans. We knew that the 612 is the good one, the 4040 is the bad one. So we want to make sure that we create a SQL plan baseline for the 612 one. And let us verify now if it's really created. And here it is. We have an enabled and accepted SQL plan baseline. That's wonderful. This is what we wanted. And in theory, what we could do is also, even though we prefer to do this individually, we could fix all statements, because we have collected all plans for all statements. We are still not big fans of this technique, because we think you would miss the chance of potentially better plans if you do so. But if your approach is, and we have this discussion with customers sometimes, to nail down all the plans, here we go. Let's load all plans from the SQL tuning set and just fix them. So we go into this capture cursor cache now. We take all plans, we say load plan from SQL set. From the SQL set here, capture cursor cache, and we want to fix and enable them. And this is what we are going to do. We loaded 32 plans. Now let's list all of them. We have a lot of SQL plan baselines now. The only one which sticks out, you remember, I didn't say I want to have it fixed. This is the one I created beforehand with Carlos script. Now I just loaded all of them blindly. So you see now two reports. All of them are fixed. The one with the red lines is the one where we the following. Change the parameter to make the statements run bad. Now the parameter. So you see the red plants.
So we again switch
and
to
the second one is now with all the
10,000.
plant baselines from the good plants being nailed down, and you
And
see
now we
all
repeat
green
exactly
here.
our tasks from before. Just don't forget to hit once return. And we are already done. You'll see this runs really, really quickly. Exit from SQL Plus, and then let's call Firefox. Let me continue now with lab number 9, the SQL Tuning Advisor. What we could do here is, this is a cleverly designed application. It uses bind variables all over the place. But what if your application is not that nicely written and uses literals and various literals, not just one or two values? Then at some point you will need the SQL Tuning Advisor. And the SQL Tuning Advisor has one significant feature which we may benefit here from. It could also nail down plans with an internal hint, but treat a single statement as if cursor sharing would be set to false, but not for the entire database, but only on a single statement level. So this is what we are going to do here. I'm connected to my UPGR PDB again. And here I run now a tuning task. Again, this script can be downloaded from the upgrade blog mikedietrich.de.com/scripts. You see, it takes a little bit longer than the previous tasks, because also here we do a simulation of some statements, and we see some output here. Let me go back. Okay. So this is my tuning task. I want a report on the tuning task. Some general information. So I used again the 43 statements from the capture cursor cache. And now the statements with results ordered by maximum profile index benefit. That means it tries now to find on a per statement basis optimizations. And for the first one here, this is the statement. So it's this SQL ID. It has several findings. First of all, it says, look, your optimizer statistics are stale. And then it gives you also the code to fix that. Better optimizer statistics lead to better execution plans. That's very simple. Index finding, the execution plan of this statement can be improved by creating one or more indexes. Now it promises 90% of benefit. Be careful. You are typically not just creating some indexes. And this is where you have to use your superficial DBA experience powers and say, look, is that really an index we would benefit from? If that index shows up for multiple statements for your applications, then it would be a good idea. But if it's only a single statement, be careful. Creating an index means also overhead. Let's assume this table has like 50 billion rows in it and very diverse data. And then you just create an index on it. This is overhead for future indexes, future inserts, updates, and deletes. And then I have also an alternative plan finding. And the alternative would be a different plan hash value. And it says, hey, we could create another SQL plan baseline for this one here. That would be an idea. And so we go forward with each of the statements and we have more and more findings. So let me go to the end here. This is now the code at the end to implement that. And what we are going to do is we implement the index recommendation if. We will create two. So I'm going to run now. Speed tasks 10. That's cool, so don't forget to push the return button. And it's the elapsed report again. We exit SQL Plus and let me also close my Firefox. I still have it open in the background just to avoid any collision here with the reports. And then let's have a quick look. I see already a green 14%.